Hoffaday students, today's lesson is about one of the applications of the derivative, which is to find the tangent line. I know you've watched some videos and we've talked a little bit about tangent lines, but we're going to see now how to find it given just the function. One important application of derivatives that we have to know here is that the derivative, if we have a function, the derivative will give me the slope at any given point of the function, right? So if I was to find the derivative, I say this is at x equals 1. The derivative right here is the slope of this curve at that point. So f prime of 1 will be your slope. Tangent lines. As you know, a tangent line is a line that touches the curve at a point and it matches the slope there, so it has the same slope. Looking at x is equal to 1, the tangent line will touch the line just at 1 and will have the same slope at 1. So it may look something like this. In this video, we're going to be talking about how to find the equation of the tangent line. So to do this, we're going to actually recall some of the linear equations from Algebra 1, more specifically the point-slope form. So for the point-slope form, all you need to know is the point and a slope, right? So you need x1, y1 for your point. You also need to know the slope m. Okay, and then the point-slope form is y minus y1 is equal to m times x minus x1 within parentheses. So like I've told you before, when you're being tested for this in an AP exam, they don't care so much that you know how to distribute and solve for y, because this is not an algebra test, right? So as long as you can put it in the correct point slope form, you can leave it there. You don't need to go any further. However, if it's in a multiple choice problem, you may have to be familiar with putting it in slope intercept form just in case they're presented that way. Okay, and now we'll just move on to actual examples. Example 1, find the equation of the tangent line at x equals 1. So this function is actually already graphed for us. 3x cubed plus 2x squared minus 5x. I know I need to find two things, a point and a slope, right? The slope is easy to find. I know it's going to be f prime at 1, right? So I'm going to find, first of all, I need to find f prime of x. F prime of x, I'll take the derivative of the function. We have 9x squared using the power rule plus 4x minus 5. So this is the function that'll give me the slope at any point. Since I specifically want to find the slope at 1, I'll find if f prime of 1 and evaluate. So substituting that in. So we have 9 plus 4 minus 5, which is 8. So my slope is going to be 8. Now all I need to find is a point, and since I know x is equal to 1 and I have a graph, all I want to do is find the appropriate y value at 1. So it's going to touch the line when x is equal to 1, so the y value is going to be 0. So we have this point right here, 1, 0. So we have a point and we have a slope. So now I can just plug it into the point slope form, y minus y1, so y minus 0 equals 8 times x minus 1. Simplifying this just one step, y equals 8 times x minus 1. If you want to go the step further and make it to be 8x minus 8, you can, but again, we don't need to. Okay, so when it's graphed for you and you have the point already there, it's super easy. Just find the slope. Looking at a second example, find the equation of the tangent line, f of x equals 2x squared plus 5x minus 1 at x is equal to 2. So what I'm going to do first is, again, find my derivative. F prime of x is equal to 4x plus 5 using the power rule. I'm going to evaluate that at x equals 2 to find my slope at when x is equal to 2. Plugging that in. And we always want to pay attention to our notation, right? Because some students tend to just equate f of x is equal to 4x plus 5 is equal to 13. which is not correct. We're going to always write a new f of x, f prime of x, f prime of 2, whenever we're doing a new thing to it, right? When we're substituting something in, when we're deriving, it's always a new equation. So we want to indicate that in our notation. And from here I can see that my slope at x equals 2 is 13. Now we need to find a point. So I don't have a graph here. You don't need to graph it. All you have to do is just find, we have an x value, right? X is 2. Find the appropriate y value. And in order to find the y value, all you have to do is find the f of x, right? So we're going to find f of 2 using the original function. So the point is going to be 2, and then that f of 2. Plugging in 2 to the original, I have 2 times 2 squared plus 5 times 2 minus 1. Using PEMDAS, we have 2 times 4 plus 10 minus 1 equals 8 plus 10 minus 1. We have 17. So we have 17 as our point. Slope is 13. Plugging it in, we have y minus 17 is equal to 13 times x minus 2. I'll just leave it here. And that's the equation for our tangent line. So the last example, we actually have one that you may have done using Khan Academy before, but we'll just go over it again. The tangent line to the graph of a function f at the point 2, 3 passes through point 7, 6. Find f prime of 2. So even though the curve right now, there's not much information is given on the curve, we don't know how it behaves, I'll try drawing something out just for us to get a better idea. So at 2, 3, one, two, 1, 2, 3. That's our tangent line where it meets the curve. And then it passes through 7, 6. 3, 4, 5, 6, 7. 1, 2, 3. So this is the equation of our tangent line. So my curve might actually look something like this. It doesn't really matter. I just know its slope matches the tangent line at that point. So now we're no longer looking for the equation of the tangent line. Now I want to find f prime of 2. And I know the derivative at a point is actually just going to be the slope. So if this is a tangent line, it's supposed to have the same slope as the point 2, 3 on my graph, right? The same slope as the function at that point. So all I have to do is find the slope of my tangent line. And since I'm given actually 2 points on my tangent line, I can very easily find the slope using algebra 1. We have the slope formula, right, which is m is equal to y2 minus y1 over x2 minus x1. It's rise over run, right? Since I have 2 points, I can say, okay, y2 is 6 minus y1, which is 3, y values, over 7 minus 2. 6 minus 3 is actually going to be 3 over 5. So it makes sense, even though I'm not given any information further than just the tangent line, I can find my slope of my function at 2, because it's just going to be the slope of the tangent line. So my answer is 3 over 5. And that's it for the lesson. Hopefully your work goes well. It seems like everyone's doing pretty well with utilizing the power rule, and now we're just looking into other applications of the derivative. So that's it for today, students. Have a good day. I know it's so rainy. Hopefully you're able to get your work done. I'll be sending you an assignment.